Okay. Here is where we left off on, I don't remember the last day we did notes. Do you guys remember that? When was that? Okay, I gave you guys a blank periodic table. You guys got this, yes? So we drew all these levels, and I did this freshman year, and I showed you how these fill. So 1s, these always fill down and to the left. If you remember, each orbital can hold how many electrons? 2 electrons. So the 1s fills like this: 1s1, 1s2. These are just electron configurations. You got it. Then you fill the 2s. So you're going to fill your 2s1, 2s2. Then you fill 2p, then 3s. So you have 2p1, 2p2, 2p3, 2p4, 2p5, 2p6, and then your 3s1, 3s2. So this is just showing why they fill. You don't have to do this if you don't want to. All right? If you got it, you don't have to do this. I'm just going to show it in case people want to see it. Then I'm going to go 3p4s. So I have 3p1, 3p2, 3p3, 3p4, 3p5, 3p6, and then 4s1, 4s2. Then I go to 3d, 4p, 5s. So 3d1, 3d2, so on. I'm not going to say these all out loud. 6, 7, 8, 9, 10. Back up to my 4Ps. 4P3, 4P4, 4P5, 4P6, and then my 5S1, 5S2. You will notice that your 3Ds trail your 4S's by how many? 1. So Ds always trail the S's by 1. That's important to know. After that, I fill my 4D, 5P, 6S. So I'm going to go to my 4Ds. Kind of sounds like I'm saying 40, like 43, 44. Because I have such a busy week. I have conferences tonight. I have conferences Tuesday. I have my daughter's conferences Wednesday. And Thursday night we're having a couple people over to our house. And then Friday I'm flying to Disney World. It's a busy week.
You aren't doing conferences on Friday?
No, we have Friday off. Because of conferences. Because we work a full extra day between tonight and tomorrow, we get that Friday off.
Oh.
That's why.
I thought conferences.
Wait, so there's no conferences that day?
No. That's our day off for doing conferences.
You guys should get more
That makes
days
me
off.
sad.
What?
I said
Why?
you guys should
Because
get
that
more
means
days
Chris
off.
is going to be there. Oh.
Why should we get more days off? So then you can get more days off?
Yeah. You guys aren't here, then we can't be.
You're right.
Friday and Saturday.
6S1, 6S2. Okay. After my 6S's, anybody remember what you fill after 6S from chem last year or freshman? You go from the 6F down to the 4Fs. This is where people usually make their mistake when they're doing electron configurations. And it shows you here, I go 4F, 5D, 6P, 7S. So after 6S, I go down here to my 4Fs, 4F1, 4F2, all the way to 14.
Whoa, what?
Yep,
Why don't you just go?
Because
that's not how they fill. Because they go 4F, 5D. This kind of shows you how they come down here.
No, I understand, but why did you go down to that?
Because I have how many F orbitals? 1, 2, 3, 4, 5, 6, 7, right? 7 times 2 is 14. There's 14 spots down here. That's why it's organized like that. So it's all related to the atomic structure, which is kind of cool. 4F8, 4F9. I got here early this morning and set up the lab too. Then I saw 7 people absent. I'm like, what in the... So then I had to ask Mr. C if it was okay. It's all good. We figured it out. 4F14. Then I go back up here to my 5Ds. 5D1, 5D2, 5D3, 5D4. Because 6S, the D's always trail by 1.
Oh, yeah.
D's always trail by 1. 5D6, 5D7, 5D8, 5D9, 5D10. Guess who else is going to Disney World this weekend? Senora Stokes. Yeah. Yeah. I think it's one of her daughter's like bachelorette celebration weekends. So, who I both taught. They're both awesome. 6P1, 6P2, 6P3, 6P4, 6P5, 6P6. Actually, I taught all the Senora Stokes kids. Grant I never taught, but he was in the first class that I advised. So, Grant, Molly, Olivia, Luke, all of them. Great kids. All great kids. So 6S, 4F, 5D, 6P. We good so far? And
Good.
that's okay. Lastly, I've got, I forgot my 7S. 7S1, 7S2. And after 7S, I go 5F, 6D, 7P. So after 7S, I go down here to my 5Fs. We have our 5F5. We have our lighting lanes already booked because you can now book 3 lighting lanes in advance. So we got starting off the day with Haunted Mansion, which I think is decorated for Christmas at Christmas time, which I'm really excited about that. Then from there, I think we go to, what was our next one?
Wait, so you're gonna, have you ever seen the Christmas?
I've never seen Christmas at Disney.
Oh, are you the first time, like the last
It's gonna
time
be
we
so
went,
magical.
It is, they have the biggest tree and it is.
I might cry a tear, I'm just saying.
We cried.
Yeah.
There's so many tears. And it's so
So this is like our exploratory mission to Disney to see what it's like at Christmas time.
you just gotta go, you know?
Because our daughters aren't going with us. It's just me and my wife. Because it's still my 40th birthday celebration. What else did we book? We booked Haunted Mansion. I know at around 2 p.m. we booked Tiana's because we wanted it to be warmer.
It's so good.
So we have that booked. What else was that one big one we booked? We didn't book Tron yet because you could only book certain levels.
That's like time.
Yeah, we'll just wait in line for that.
The Avatar
Was it
one
7
good.
Dwarfs?
Yeah, we need to do Avatar.
You got a lightning.
Avatars. No, I don't think we
You ride
did.
on the things and
But that's not in Magic Kingdom. We're only going to Magic Kingdom. Avatar's in Animal Kingdom. I did ride that when like the bellies are breathing.
Yeah, it's weird.
It's really cool. 5Fs and then up to my 6Ds, 61, 62. We're gonna eat at Tony's on Saturday night, the Lady and the Tramp restaurant. And then finally 7Ps. 7P1, 7P2, 7P3, 7P4, 7P5, 7P6. All right, I gotta really think about, I'm gonna have to pull this out and see my Disney app, where that third, we didn't need to know. I know you guys wanna know.
Oh my gosh, have you ever had Pico's Bill?
I have not had Pecos Bill.
They took away the
Fajita platter, which is the best literal food you can get in one entire park.
You know what's bad? You know why my family loves Disney? When my dad texted that exact thing in our group chat and, like, people were devastated. That's how you know.
That is devastating. Oh, 805 to 905, I have Haunted Mansion. 950 to 1050, Pirates of the Caribbean.
That's good.
That's classic. You have to ride that.
Like, run past, like, literally
Do you
everyone.
say
'cause the-
Caribbean or Caribbean?
However you want to say it. And then 4:30 to 5:30 is Tiana's Bayou Adventure.
Bio.
Bayou, yes. Which we watched Princess and the Frog this weekend with our daughters to get us ready for
Right, obviously.
for it. It's really good music. If you guys have you guys seen that?
It's so.
The music in Princess and the Frog.
It was really a
They play like all the
that they
songs
didn't
on
have the like the big droppy like into like the like shadow like voodoo thing. I think
Ah.
that was a really big missed opportunity that they should have done. Like that would've
Isn't
been
this?
cool.
I read that it was like I haven't seen anything on it because I'm trying to like get no
Yeah,
spoilers.
You don't wanna.
Isn't it like a continuation of the movie?
Yeah, because she's like.
No,
making-
not really.
Oh, it's not. Okay.
It's kind of just like a Bayou thing.
Have you read it? Rode the ride?
Yeah.
Okay. Okay.
Kind of like Splash Mountain.
Have you read it?
They still have some of like the animals from Splash Mountain in it.
Oh, sweet.
Like, it's
I didn't know that.
part of that, but-
I just think
Yeah.
I think that was a
Well,
huge
'cause they
missed
were
The
just
Witch Lady,
switching the
the Witch
theme of
Lady's
it.
part of it though.
What's her song?
deeper.
You gotta dig a little deeper. Yeah,
Yeah.
I like her.
They play at the end.
She's a queen.
All right, are we good with this? So this is how they fill. I should probably attach this to the notes for people that aren't there today. I'll do that. Unless anybody wants to take one for a friend. We good?
I'll get mine.
What?
I'll get mine.
Okay. All right. So, what do we do with this? I'm going to flip my page. We do what we know as electron configurations. So, electron configurations. This allows us to show where an electron is located for any element from hydrogen all the way down to uranium. Because our Bohr models, right, freshman year only went 2882, yes. So you can only really build a Bohr model up to calcium. Well, now we can say where electrons are located for anything. For example, hydrogen. What would be the electron configuration for hydrogen? First of all, how many electrons does hydrogen have? One electron. So that means I need to fill one box. So that is 1s1. What about helium? Helium has how many total electrons? Has how many total electrons? 2. So I need to fill both boxes. I'm not assuming, I'm pretending like no one has done this before, okay? Do I write 1s1?
Yes.
No. I write the last box that I fill. So if I write 1s2, right, that is showing that I have both of my 1s orbitals filled.
Is this when you have one that's like literally all the way at the bottom and you have to like write like a million?
Yeah.
Yes.
But it's writing them all out.
You got it.
Isn't there like a shortcut?
Yeah, you can
There is.
like,
There is.
Is it the noble gas?
The no
Yes.
gas?
Yep. You got it. Oxygen. Oxygen has how many total electrons? Huh? 8. So do I need both of my 1s's? So that's going to be 1s2. Do I need both of my 2s's?
Yeah.
2s2. And how many of my 2p's do I need?
4.
2p4. 2p4. Now, cool thing about this is, how many valence electrons does oxygen have?
6.
You would agree that oxygen has 6 valence electrons. It's in group 16, yes? The highest energy level for oxygen, you would agree, is 2, yes? What is 2 plus 4?
6.
So electron configurations also can show you valence electrons. All right, that's really important.
Balls on your tie that one.
Really important. So, and also 2 plus 4 is what? 8. So these should always add up to your atomic number or number of electrons. You can check your answer.
So the last two will always be added to be a valence.
It depends. It depends. The highest number.
Oh, okay.
The highest number. This is my highest level or my outermost. So 2 and 2, 2 plus 4 is,
So like that 2p could go to.
yes. Because these are both 2, those are my outermost electrons. Okay, let's look at phosphorus. Do you want to try that one on your own?
Yeah.
Okay, try out phosphorus on your own. I will hydrate. You guys are drawing some phosphorus. I'm getting some sound effects here, some ASML for notes. ASMR, sorry. ASML is the stock that I own. They, you know what ASML does? They make pretty computer chips. Yeah.
I wonder how Andy.
I think it's hilarious that you remember him by his first name.
Andrew Cochran. Don't even know what his middle name is. Though.
Probably can figure it out. I don't.
It could be Lucy Quigley.
It's probably like.
I probably have it somewhere in my files because I print off my rosters every year.
Do his address. I'll look him up on LinkedIn.
I just,
Oh no, I can look him up on LinkedIn on our website. Don't even worry.
I don't think he lives here though.
Sure people search.
He said he lives in
Look up on Sure
Pittsburgh.
people search. You can find anyone.
Phosphorus. 1s2. 2s2. He does what in his free time?
Derek finds
Look,
people.
No.
Oh.
We
2p6.
didn't find someone's data like 2 years ago.
That's weird.
3s2.
He probably has all
And what's the last one? 3p3. Okay, do you guys remember doing these? So for 1s, right, 2, I would have 1 up, 1 down.
Oh my god.
What's this called?
Dude,
What are these called?
It's
For 2s2, I would have 1 up, 1 down.
because they can go.
Do you guys remember the off-ball diagrams?
It's a two-way.
These are called off-ball.
Dude, I would.
So off-ball, we know that we have to fill the lowest energy first. The lowest energy fills first. Lowest energy level filled first. And then we also know that Hund,
Can you zoom in like on that spot?
sure can. All right. Off-ball says lowest energy level filled first. Hund said to fill the ups first. So off-ball, lowest energy level filled first. Hund, you fill the ups first. What does that mean? Well, for phosphorus, for my 2p6, I have got 1, 2, 3 orbitals. Agreed? Yes?
Yeah.
So I would fill up, 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 yes, and then my down, down, down.
I remember that.
Okay? 3s2, here's my 3s2, up, down, and then my 3p3, 1, 2, 3. How am I going to fill those? Up, 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 up. So, yes? So phosphorus wants to do what with 3 electrons?
Go up.
It wants to pair 3 electrons here, right? Which means it wants to do what with 3 electrons? You can see what it wants to do. It wants to gain, right? Phosphorus wants to gain 3 electrons. It wants to have no unpaired electrons. We're going to talk about paired, unpaired, what that means in a little bit. So that is phosphorus. Let's do a long one, just to have one long one for fun. Okay? Just for funsies. So let's do mercury. So do not the off ball. Okay, we're not going to do that's crazy. Okay?
I was gonna say that.
Just do an electron configuration for mercury. Hg number 80.
What about the shortcut? Yeah, can we do a shortcut? Can we do a shortcut?
After this. We need to do the long version first,
Number 80.
Yeah.
just so you have practice.
We complain so much.
It's okay. It's all good. It's Monday. A little bit of complaining is allowed on a Monday. The good thing is you want to do this on your own tonight for an hour. So,
That is true.
yeah.
Thankful for
Do we
that.
have any book comments?
Yeah, the book problems are up there for the chapter.
Hey, that's a good amount.
It's not too many this chapter.
We like that.
Yeah.
And then, but the 1 to 15 are multiple choice.
Oh, okay, I see.
Oh, I didn't see
That's
the 1
the
to 15.
kid.
I thought that was single ones.
1 through 15. But those are multiple choice. So,
Okay, but you're gonna have to do work before you pick the multiple choice.
So what does it do?
day of the test.
And that is.
Are we gonna?
Let me look that up. While I'm looking that up, I will print you a new one. You need a new one-sheeter, Maddie?
Yeah.
Okay, let me look that up. I think I told you. The test is next Thursday. Next Thursday. And then we will have 1 day of notes. No, then we'll have 2 days of notes and then Chemsgiving. Wow, that's crazy. Yeah, we got to get Chemsgiving planned.
Yeah, I agree.
Yeah, we're going to work on that this week. Let me find that one pager for you.
A, B, C, D, E.
My desktop is out of control right now.
You hit that second line
Yes,
of filling.
I know. I know.
You know,
I agree.
like where's the noble gases when you need them? You know what I mean?
Where are those little gases?
Wait, is that when you use like the brackets around the?
Yeah.
I
Yes.
remember
I'm
that.
remembering.
Mm.
Because we did this freshman year too.
We did.
So we've done it twice.
This is the third time you've done this if you had me as a freshman.
What is that?
All right, while you guys are finishing that, I'm going to go grab Maddie her paper.
Thank you.
You got to dig a little deeper. Soon time the sunshine, you got to dig. You got to dig. You got to dig a little deeper. dig a little deeper.
Yeah, that doesn't start till the second test. I was wondering what the nails are allowed.
Man, that went fast.
We're already.
I know. It's crazy. All right.
We need a law, please.
I'm just gonna come check everyone's.
He just shows up
Yeah.
genuinely.
Got it.
Like, oh, time to get in the pool.
And I can do this.
Okay.
I kind of feel like, I looked up, have you seen all like the old money buying stuff?
Yes.
That is my life. I love being.
Oh, you didn't have to do the
Like,
opal.
that's what I'm gonna, yes, that's what I wanna be.
Was he doing the?
Or that,
Yeah.
and Costco.
But good job. Good job.
Wait, did you do the?
Overachiever.
All right. Mercury. Several of you have this. Several of you do not have this correct. That's okay though. Several of you have it. Several of you do not have it. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Is it weird that I had these memorized?
We forgot to put the 4S in.
Yep. 4p6, 5s2, 4d10. I didn't say who didn't have it. I just said some people forgot. 5p6, 6s2. After my 6 S's, you must fill the 4 F's.
Oh, I forgot about that. I did it, but I'm better than
4F14, and then 5D10.
14.
Yes. So remember, you can always check your work. If you would have checked your work and added up all of your numbers, you would have been short by, guess how many? 14. You would have only had 66 electrons instead of 80. You can always check your work. If I asked you, how many valence electrons does Mercury have, what would you say?
Wait, but you
Or is it the highest number?
How many valence?
How many valence electrons?
No. No, 18.
7-2?
How do you have that many?
18.
Okay, it's the highest. That's what I know.
Only has
Oh,
2.
I forgot 6 is in there.
So note that this is not the last one in electron configuration, right? So the highest energy level may not be necessarily the last one you write down. That's really important to understand. That's the highest energy level, that's the outermost. Yes?
What if it ends on like 6, P, like whatever?
Okay.
Would you add the 6P?
If there was also 6p, you would add it to the 6s.
Yeah, okay.
You got it. Audrey, you cool with that?
I think that makes sense. So
This is the highest energy level, therefore the outermost.
I get it
the
now.
energy level includes
So
everything
this
that has like, it has
SPE.
14.
Correct.
plus 10.
Yes.
It goes to the-
You got it.
That's the same one.
Which is why we drew, right? This kind of shows these energy levels going up. It's kind of, not, it doesn't just look like this, but you're building those levels. That's why right here, 4th energy level, 4s, 4p, 4d, 4f. So this is all kind of related. Yes. Okay? It's really cool when you like are starting to like understand this. Okay. So what would the short form look like for this? So the short form, AKA, we call what? Noble gas notation, right? Noble gas notation. So we go to the previous noble gas before Mercury. So we have to go backwards. What is the noble gas before Mercury? Xenon. So I would put Xe54 in parentheses. So that covers for everything up to my 6s2, 4f14, 5d10. So that is the short form for Mercury. Okay. Last one. Then I know we got it. Let's do something kind of mid.
Mid PUD.
Cobalt. Give me electron configuration, off-ball diagram, and short form. Okay?
Wait, where even is it?
Cobalt is number 27,
Yeah.
Oh, I see.
so it's kind of mid.
Yeah.
So electron, off-ball, short form. Or if you're William, you could just square the ones that you did. Just square the ones that would be for cobalt. Slept with my neck wrung last night. I hate that.
That's the worst.
Yeah.
Am I, like, right here has been so tight these past couple of weeks. I don't know if it's like from Andy or whatever, but like.
Short, long, and off ball.
It actually it hurts so bad.
I found in my, so I have like this like stack of gift cards I had like I found in my desk at home. I found a Chipotle gift card. No, I know it's for dinner. I got from 3 to 4 open. Gonna go get some Chipotle right before conferences.
We were really talking about how good that
I want
sounds.
Chipotle right now.
I do too, but I'm gonna have to wait about 4 hours.
Oh, that's
It's not bad. I'm not eating lunch because it's like weird. If I ate lunch, then 3 hours later I wouldn't be hungry.
yeah.
Does that make sense? So I'd rather be really hungry.
Being really hungry and then eating Chipotle.
Oh,
is
it's
literally
glorious.
so-
When you're doing a bottle box, you have to do every energy level involved in it.
Or
Yes.
explain the-
Hot takes. The
Oh, wait.
old Chipotle is like downgraded since the new one's open.
Hot take. Really?
Yeah.
I haven't been to either. in a
Like the
while.
old one is not as good anymore.
I haven't been to the new one yet.
The new one's both.
They kind of give you a lot more food. It's like there.
How do I know how many lines?
2s2.
Yeah, it's in the OS.
Ooh, I should have drawn that there. That should really be here.
So you divide each one by 2, and then however many there are, that's how many lines you have.
We know that there's 3 p orbitals, right?
Oh, I'm
All of
getting
them are full.
Right.
Are full
S has
until you get to the line.
1, D has 3.
I just had to think about that. What? That's a 7.
So 3s2, up, down, 3p6, up, 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 down, 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 4s2, up, down, 1, 2, 3, 4, 5. I would have up, up, up,
Down,
up, up,
down, down.
down, down.
Wait, how do you know how many orbitals are in the last one? Again?
Because I have 3D, D's have 5, right? Because I know that, because there's 10 total in this section. 5 times 2 is 10. Or, if we go back, we know that my D's can hold 10 electrons. So either way. And I have to go up, 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 down, down. That would be,
Wait, which version did you like use?
what do you mean?
Like you said you can either go from, oh, both of them get the same whether you.
Same thing.
Lowest energy level go first.
Same thing.
Yeah, see, standing at the end. Yeah, also because there's I'm not trying to like sit on.
And then the short form would be what?
AR-18.
AR18. 4s2, 3d7. So if I asked you, what electrons would you remove first from argon, what would you say? The 4s2 electrons. You would remove these first because those are the highest energy level, therefore the outermost.
If I know
Therefore,
how
the
to do
utmost.
electron configuration, then my life would be pretty small.
Not gonna lie,
Well, the
this
good
better
news
than
is,
everything else we've done.
Yeah, true. This is like to make my
the good news is you probably won't have to write out an electron configuration on the AP test, but you'll have to like just understand what it
Yeah,
is.
like I know how to do
Like,
it. It's
notice
just,
it.
It's just so tedious.
Yeah, like this.
Like identify it.
Like what if I said, what is the electron configuration for Ca plus 2? Draw that electron configuration. Could be, it'd be a good multiple choice. But draw the electron configuration for an ion of calcium, which is plus 2. Draw it. Just E config. Just write it out. 1s2, 2s2, write that out. Right now. Now we're at an ion of calcium.
Wait.
You gotta think about what that means. You can do this.
But why?
Is it not the same?
It's not the same. Think about what this plus 2 means.
It means that it needs.
Not out loud, in your head. What does that mean?
Oh, I got it.
You got it?
To guess.
What's your guess? You read it, I'll write it.
1s2,
1s2,
2s2,
2s2,
2p6,
2p6,
3s2,
3s2,
3p6,
3p6.
4s4.
I stopped at 3p6. I stopped at 3p6.
So we have two different things.
Yeah, because that was.
So I either have 4s4 or I got 3p6. You have to remember what a plus 2 means. If you became a plus 2, what did you do with 2 electrons? You lost 2 electrons.
Yeah.
So just because that's a positive does not mean you added. It's because when I have a plus 2, was I reduced or was I oxidized? Think about it like that. I was reduced, right? So if I lose 2 electrons, I now have, right, a full outer shell. Yes?
Yeah.
I have a full outer shell now. Because how many electrons? 2 plus 6 is 8. So many different ways to look at this.
So if they just showed me that, how would I not confuse that with argon?
You wouldn't, because it's essentially the same thing.
Okay.
Ca2 plus is argon because it has 18 electrons. Now, this would have a different number of protons. That's how you would know. You ready for one more?
Yeah.
F minus 1.
That's what it's gonna look
This is what it would look like if I asked the electrical configuration for calcium ion.
So they're not gonna ask like right out this, it's gonna be more like.
It'd be something like this. So try a fluorine ion. What would that look like? So now I'm a fluorine minus 1. What would that electrical configuration look like?
Would there be an extra square? Because it's.
What does that minus 1 mean?
There's added one electron. So
So-
go from 2 to 5.
So the short form would be any 10.
box.
The short form would be
Is it
any
2 to
10.
6? Yeah.
The short form
Any 10.
would be any 10.
How do you do the short form for like a noble gas?
It's just itself.
Oh, it's like.
Yeah, just itself. So fluorine, 1s2, 2s2, it is no longer 2p5, it is now 2p6. How many outermost electrons do I have? 8. Full outer shell. Full outer shell. Short form, somebody said it, would be what? Ne10. It's the same thing now because it wants to be like neon. Cool?
So is this what our next test is about?
This and a little bit more math. This test is actually way easier than the test we just took.
Let's go.
I think it is.
That's what we just took.
Yeah, I thought
I think it is.
I think
I did a review and everything, and
I think it was just a last question on that test. I thought it was because I didn't.
You guys overthought the last question.
I definitely did.
I
I was like
literally
writing
thought
them.
You guys overthought the last question.
all the time. I literally went home and I was like, Mom, remember that chem test I talked about being so nervous for? I think I ate it up.
Say it. Say it.
What did I talk about?
She did. She did. She did.
Okay. Write out these 4 electron configurations.
Yes, I.
The class average was a 76. So
Oh, great.
the class average was a 76, which is good.
Actually?
The class average was a 76.
Okay, so that's fine.
So it gives you an idea of where you are to the average.
Did she give you my test?
It's already in.
Below it.
I'm below average.
I'm simply studying over there.
You better check.
Yeah, I'm gonna check.
Did you guys write out these 4?
No, what they.
These 4 electron configurations.
The reason why the class average is above is that.
Probably not.
Wait, what did you get? I get 5.
What did who get?
Kel got like a 90 something.
Yeah,
Kelly
Kelly
was
was
like
like
2
2
points, but she said that was the highest level test that she got.
Yeah, several people crushed it.
I didn't do that. I thought I crushed it, but
Here's,
I did like.
because we haven't gone over the test, but I will tell you the thing that hurt a lot of people. Remember, I can't grade something if it's not there. On the Hess's law, after you did the Hess's Law, you had to do PIVNERT. A vast majority of people didn't even do the PIVNERT.
Yep, that would be me.
And that was 5 points gone.
That'd be me.
5?
That was 5 points.
I'm hurting.
Because I asked for the moles.
I think I did like, dude, I did QSMAT after.
I was
Yeah.
running out of time anyways.
Yeah,
I really.
I did like, why did I
I don't
do
think
that?
That, because I gave you a pressure,
I was gonna say,
a temperature, and a volume.
Yeah, I was like, why is there all this extra stuff?
And I literally remember
For
all the
PIVNERT, which I think was like the review sheet.
It was. I did the review sheet. I don't know why.
Review sheet.
I don't know why.
I did the review sheet.
Review sheet and you will pass the test. If you can memorize the review sheet.
Not necessarily,
That's what I've been doing.
but there was more than the review sheet on the test.
But the review sheet was a good
Make
chunk.
it a question.
I knew there was gonna have to be PIVNERT somewhere because you had it written on the needed equations, but I never found it.
And I had PIVNERT on I wrote PIVNERT up on the board. I thought that was the clue.
I knew I had to use it somewhere, but I didn't know where.
It's okay.
Wait, so for future reference, everything written on the board is going to be used?
I mean,
I mean,
I'm not trying to trick you guys.
I saw it and I was like, I
That
know
is not my goal.
but I don't care.
Which, write this question down. Electron configuration,
it was like.
write this question down,
Bagel, cream cheese, and strawberry.
shows an atom in its excited / promoted, yeah,
Let's go.
state. So which electron configuration shows an atom in its excited / promoted state? The third one.
What?
I didn't even look at it yet.
Has to be, right? Because 1s2, 2s2, 2p1, that looks regular, right? 1s2, 2s2, 2p2, that looks good. 1s2, 2s1, 2p1, that does not look right. So what I did here is I promoted an electron up a level.
Wait, you can do that.
You can, if you throw energy at it. And then once that electron jumps back down, what does it emit? Light. And that light is emitted as a color.
Wavelength.
It's a wavelength, which if you look at that through a diffraction grating, like we're going to do in lab tomorrow, you're going to be able to calculate those wavelengths. That's what we're doing in lab tomorrow.
So basically.
Yes, constantly, jumping up, down, up, down.
This is green. It's because they're constantly doing that.
Well, the green, that's pigment. That's just light, reflecting.
This is like yellow.
So like what if
This color, if you look through this, that's white light, so you're going to see all the colors. If you only have one element, yeah, it is cool. That's also how you know it's in a star. All right, if you look through a diffraction grating through the Hubble Space Telescope, or now through, what's the new one?
Magnifying glass.
What's the new telescope?
I have no idea.
What is it? James Webb. If you put a diffraction grating in front of James Webb, it's going to give you a spectrum of a star. And we're going to know that a star is made of helium, hydrogen, and iodine, or helium, hydrogen, and krypton. Pretty cool. Does someone have a question? Okay.
Oh wait, I did have a
Yes.
question. What's your favorite thing to look at through prism? What'd you call it?
Diffraction grating?
Diffraction grating.
I think my favorite element, just without a, because when you split it, you're just seeing lines.
Right.
I think my favorite one to light up, though, is probably Mercury, because it's like really blue, which I think is one of the ones tomorrow.
Oh, is that what we did that in that one lab where the light like changed color?
Yeah, I think in chem you just literally just go in there and look at them.
Yeah, we did.
But we're gonna do something with it. Yeah. Yeah, we're gonna actually do something with that tomorrow.
Mr. O was like, hey, there's this thing set up in there. Go look at.
Wait, is
That sounds
what
like-
we did at, Who it will?
No, that is the flame test lab, but that's the same thing. Flame test lab, we're exciting electrons with heat. In this lab, we're exciting electrons with electricity. So, we're done with this. Go back to your packet now. Look at that. Look how I had that. Wow. All right. So, back to our packet. If I'm using high energy ultraviolet, because we're talking about promoting electrons, this is exactly where this leads back into. It's like I planned it like this. This is the packet of notes where we left off. UV or X-ray photons, it's possible to, like I said, eject an electron from an atom. This is called the electric effect and is used to show what you did on Friday, photoelectron spectroscopy. I can't spell spectroscopy. Or, as I like to say, PES. Photons used to attract electrons have energies calculated using the relationship between Planck's constant, H, and frequency, V. In order to do that, you must know what Planck's constant is, which is on the yellow cards. It is 6.626 times 10 to the negative 34th joules times seconds. Anyone who has taken physics should know that. Photoelectron spectroscopy. Spectroscopy. So spectroscopy. S-P-E-C-T-R-O, scopy.
I got it.
To the negative
Can we say it
34.
one more time then?
Photoelectron spectroscopy. So H is 6.626 times 10 to the negative 4 joules per second, and H is Planck's constant.
Wait, to the negative 34th?
Yes. Planck's constant.
Joules times what?
Joules times seconds. We know that C is equal to wavelength times frequency. We talked about that earlier. So if I rearrange and substitute some things in, frequency is equal to C over wavelength. You guys with me so far? I haven't done anything new. This is what we talked about the day before. So if I rearrange, yes?
What is C represent?
Speed of light. Speed of light. So the energy of a photon is equal to Planck's constant times the speed of light divided by wavelength. That is combining all of those into one equation, which is a super easy plug and chug combo. Yes, super easy plug and chug equation to use. You can also calculate the energy emitted from promoting an electron if you know what energy level it was promoted to using the following equation. Triangle E equals, here's a weird constant, negative 2.178 times 10 to the negative 18th joules, that's a constant, times 1 over NF2 minus 1 over NI2. What does that mean? Well, N is the level. So it's wherever it ended at from wherever it started at. So if it started at the first level, right, and it ended at the third level, right, this would be 1 over 9 minus 1 over 1. You just literally sub in the numbers of the levels. So I would say an electron jumps from the second level to the fourth level. So you would put 2 here and 4 here. So 1 over 4 is squared is 1/16. 1 over 2 is 1/4, and then you multiply it. It's a plug and chug. If an electron jumped from the second, the initial, to the fourth level, it's plug chug. It's an easy one to do. If the energies exceed, do you remember the soccer ball in the ditch? Yes? It's almost like I planned this.
Yeah.
I've actually rearranged this chapter this year, and I think it's like going to make more sense. If the energies exceed the ionization energy, they also add kinetic energy. So instead of getting the ball just to the top of the ditch, you could actually get it out and have leftover energy, right? So that means that HV is going to equal your ionization energy plus your kinetic energy. Ionization energy plus your kinetic energy. We're going to finish this perfect timing. This is going to help you for that little 2-pager to make sure you know what's going on. So this is what photoelectron spectroscopy looks like. What you have to know, here on this graph is the what? That's the nucleus. That is the nucleus. So you can see the farther I get away from the nucleus, what happens to the energy required to remove an electron? It decreases by a lot, right? In fact, I can almost do like here, I could do a dash there, right? I could also do a dash here. Yes? I could also almost label this like 1s2, 2s2, 2p6, 3s2. Yes? Does that make sense? Would you agree that this peak is 3 times the height as this? That means there's 3 times the electrons. This is the photoelectron spectra for what element? Magnesium. Magnesium. So, things to note. Energy is measured in megajoules per mole. That's not something you're going to be calculating. It's just something you need to know. Energy gets lower moving to the right. Why? Well, why? We just answered that. Farther from the nucleus. I am farther from the nucleus. And this to be proved by what? Star, 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 star.
The one number thing, the Coulomb's law.
Coulomb's law, yes. Coulombs, Coulomb's law. Because Coulomb's law said, right? Closer together, higher the energy, right? Higher charge, higher energy. The farther apart, lower energy. So, real quick, we'll end here for the day. What would the photoelectron spectroscopy of sodium look like? So let's put our number of electrons here and energy here. So just draw me some triangles. Draw me some triangles. Yeah, like for example, triangle. I guess it's more of a peak than a triangle. Draw peaks.
I don't think I did that very good.
And these peaks have to be proportional to each other, right? It's real nice. Wow. I love that. I think I'm going to go see A Christmas Story with some of my friends up at Playhouse Square.
I'm so excited.
Yeah. You guys done?
Yeah.
So this would be 1s2. Then I have a big jump in energy, way less. That's going to be 2s2. Then I'm going to have 3 times the height of that, 2p6. That's not it. There's still one more. This would have to be half the height,
What are you kidding?
right? Because I've got 1s2, 2s2, 2p6, 3s1. 3s1. That should really help you finish that back and front that's due tomorrow for that.
Wait, this?
No, we're going to finish these notes later. The page that's due tomorrow is that front back one pager from Friday.
Remember the